Okay, I want to cover the remaining part is section 3.2 and 3.3 today because I didn't finish it. These are two sections today. So you can check here. This one. So I want to talk about some of the remaining part in section 3.2, the properties of determinant. It's like more properties about determinant. I talked about these kind of things today, review very quickly. The A and B are M by M matrices. The determinant of transpose of A is same to determinant of A. The determinant of A times B is the determinant A times determinant of B. The determinant of the inverse of A is the 1 over determinant of A. The determinant of constant C times A is C to the power N. What's it like N? This N is here. This N is exactly same to the number of rows. The same to number of rows. The determinant of A to the power R is as like outside the determinant of A to the power R. So I already proved these kind of things. You can read by yourself, these whole kind of things. I will explain the 3 and the 4 and 5. You can only read the second part or first part by yourself. So here, this equation, the A and B 4 by 4 matrices, determinant of A is -1, the determinant of B equals 2. Compute the following. Was it like a determinant AB? Here, the first one, the determinant of A times B. We can distribute determinant A times determinant B. The determinant of A is here, the -1, the -1 times. The determinant of B is 2. So we have like this, we have -2. This is the answer of first question. The second one, the determinant B2 power 5. So what's that? You can use it like last property from the previous pages. So exactly the determinant of B to the power 5, like this. The determinant of B is here. We have 2. We have 2 to the 5. Answer is 32. Third one. The determinant 2 times A. 2 is like a constant. You can check. This is was it like a number below the A. So exactly same to 2 to the power 4 times determinant of A. So 2 to the 4 is 16 times determinant of A is here, -1. Answer is -16. The first one. What is determinant transpose of A times A? You can distribute determinant, the determinant of transpose of A times the determinant of just A. You can use like a first property. The determinant of transpose of A is exactly same to determinant of A. The same times second one, determinant of A. The determinant of A is here, -1. We have -1 times -1. We have 1. The last one, the determinant of A times B to the -1. So what's that? Similar. You can distribute determinant A times determinant of inverse of B. You can keep determinant of A. Was it like a determinant of inverse of B? So we can use like some property, exactly same to 1 over determinant of B. The determinant of A is here, -1. times 1 over the determinant of B is here. We have 2. Answer is negative 1 over 2. So that's it. This is the whole idea for solving this problem. The last problem, let A, B, and C be 3 by 3 matrices with determinant of A equals 9. The determinant of B equals 4. Determinant of C equals negative 3. Compute determinant of this kind of things. So what's that? This is same to, you can distribute. Determinant of 1 over 2, A to the minus 1, like this, like inverse of 1 over 2A times determinant of transpose of B times determinant of C cubed, like this. So here, this is like inverse. You can change it 1 over the determinant of 1 over 2A times the determinant of transpose of B is exactly same to the determinant of B. So on times. Here, it's like outside. We have determinant of C to the power 3. So like this. The next, you can take 1 over 2 by using 1 over 2 to the number of rows. We have 1 over 2 power cube times determinant of just A times determinant of B times the determinant of C to the power cube. So what's that? 1 over 2 cube is 1 over 8. The determinant of A is here 9 times 9. The determinant of B is here 4. The determinant of C is the negative 3. So we have times negative 3 cube. To simplify, 1 over. The 1 over 9 times 9 is 9 over 8 times 4 times the negative 3 cube is negative 27. So you have to use reciprocal. 1 over 9 over 8 is 8 over 9 times 4 times negative 27. The 9 is crossed out. Change 3. This is same to like it is. Let's check the answer there. Right, yes. The 8 times 4 is 32 times negative 3. Answer is negative 96. This is answer of the last question. Okay, this is all for section 3.2. The next, we are going to section 3.3. Here, section 3.3. The section 3.3 is Cramer's rule. The Cramer's rule, what's that? The outline. Was it like a Cramer's rule? I'm going to give you examples. The Cramer's rule. The Cramer's rule can be used to find the solution to the linear system of equations Ax equals B when A is an invertible square matrix. For any n by n matrix A and any vector B in Rn, AIB, what's AIB? Is the matrix obtained from A by replacing column I by the vector B. This is like AIB. What does it mean? The next one. The vector A is given. What's like a vector A? Here. The vector A, the matrix A is like vector A1, vector A2, keep going, vector AI minus 1, vector AI, vector AI plus 1, Keep going, vector AN. This is exactly matrix A, n by n matrix. Only replace ith column by vector B. Here, only replace. Like this. Exactly same. Here, this last part is same, only replace AI by vector B, the ith column. So like this. This is AIB. As Cramer's rule, let A be an invertible n by n matrix for any vector B in Rn. The unique solution vector x of Ax equals B has entries given by the determinant AIB over determinant of A. So that's it. This is exactly xi. Okay, how can prove? Proofs like this. The matrix A is given, the A1, A2 till AN, n by n matrix. We can think about the identity matrix, the E1, E2, En, or something like that. Was it like E1? Was E1 is, was it E1? E1 is like 1, 0, all things zeros like this. This is E1. Was it like E2? E2 is the 0, 1, 0, other part is all 0. It's like E2, the keep going, this kind of things, exactly identity matrix. Was it like IIX, only replace the vector X, to replace the ith column by X. Was it like X? Here, vector X is exactly same to here. The X1, X2, keep going, Xn. It's like X. Was it A times IIX? We can use it. The vector A, the IX is this one, is here. The next distribute A. Distribute A, so we have it like this. So AE1 is exactly same to A1, AE2 is A2, so keep going. So AEI minus 1 is AI minus 1, AX is B because we have this one. This is the reason. So like this. AX equals B. AEI plus 1 is AI plus 1. AEN is AN. So we have this kind of things. So this is exactly same to AIB. The AIB is exactly same to A times identity. This is IIX. The IIX is only replace ith column by X. So like this. We can take a determinant both sides, here and here. Take both sides. The next, distribute determinant. So we have it. So was it like a determinant Ix here? This is exactly same to xi. So determinant AIB by making cofactor expansion along ith row here. You can use cofactor expansion along the ith row. So divide the both sides by determinant of A only. Divide both sides by determinant of A. That's it. So we have it. This is, the whole idea for solving this problem. I want to give some examples here. First example, use Cramer's rule to compute the solution to the system. So we can change the system to the like this. Here, the AX times B form. This is 4, 1, 5, 2 times x1, x2 equal 6, 7. Same to A times vector x equals B form. So like this. So what's that? A is given. So we have A is given. A is 4, 1, 5, 2. What's it like A1B? You calculate A1 vector B. So what's that? You can only replace first column by vector B. So First column is exactly vector B, 6, 7. Replace, you can keep 1, 2. Was it like A, 2B? So in this case, you can keep first column 4, 5. Only replace second column 1, 2 by vector B, 6, 7. So like this. The next, you can calculate the determinant of A here. So was it like x1? x1 is determinant of A1B over determinant of A. Like this one. Was it like x2? x2 is determinant of A1, A2B, sorry, A2 vector B over determinant of A. Like this here. The determinant of A1B is determinant of this one. So we can use the 6 times 2, 12, minus 1 times 7 is 7, over. The determinant of A is here, 4 times 2, 8, minus 1 times 5, 5. Answer is 5/3, right? Was it like x2? The determinant of A2B here, 4 times 7, 28. Minus 5 times 6 is 30. Over. The determinant of A is 4 times 1, 4 times 2, so 8. Minus 1 times 5, 5. The same to this denominator. So we have negative 2/3. So that's it. Was it like answer? Answer is like this. Was it like a vector x? So we have x1 and x2. This is answer. Answer is here. The x1 is 5/3. x2 is negative 2/3. That's it. This is exactly vector x. We compute by using Cramer's rule. The next one, here, the similar. You can change this one to the AXB form. Was it like A? A is the first one, 3, minus 1, 0 is the first column. This is like x1 part. x2 part is the 1, 2, negative 1. x3 part like 0, 1, 2. This is like A times vector x, x1, x2, x3 equals vector B, 5, negative 2, and minus 1. So we have it. So like this. The next two. This is what? Same to A times vector x equals vector B. So we have matrix A. Was it like A? A is here. A is 3, minus 1, 0, 1, 2, minus 1. 0, 1, 2. Was it like A1B? This one is only replace first column by vector B, the 5, negative 2, and minus 1. You can keep second and third column. 1, 2, minus 1, 0, 1, 2. The next one, A2, B. So you have to keep first column, 3 minus 1, 0. Only replace second column by vector B, 5, negative 2, minus 1. 5, negative 2, minus 1. Third column is 0, 1, 2. Was it like A3? This is, you have to keep 3, -1, 0. The 1, 2, -1. Only replace third column by vector B. The 5, the -2, -1. This is like A3. The next, the was it like x1? X1 is determinant of A1B over determinant of A. You can calculate determinant of A1B, determinant of A. Was it like x2? The determinant of A2B over determinant of A. X3 is the determinant of A3B over determinant of A. So we can calculate these values. So this one is like here. Can change it. This one. Here and here. So we have it, exactly previous one. So you can calculate the determinant of A. What's like the determinant of A? Here we can calculate. This is the 3, 1, 0, -1, 2, 1, 0, -1, 2. So let me see. I will interchange first and the second law. The same to keep negative -1, 2, 1. We have the 3, 1, 0, and 0, -1, 2. So we have it. The next, you can choose P1 -1, eliminate 3. This is like first law, second law, and third law. So we use this one. Second law plus 3 times first law. So what happens? Keep negative. You have to keep -1, 2, 1. The third law, 0, -1, 2. You can replace. The 3 times, the 3 plus negative, the 3 times -1 is like 0. So here, we can calculate this one. We have second law, 3, 1, 0. 3 times the first law is -3, -3, +6, and 3. You add it. So we have 0, 7, 3. Like this. So next, how can you calculate? Keep negative. You can choose this one. So we have 2 zeros. You can choose this one. So what's that? First one is positive, negative, positive. So this is -1 times, what's that? You can eliminate the first row, first column, only 7, 3, -1, 7, 3, -1, 2. So -1 times -1 is +1. 7 times 2 is 14, minus -3. Exactly 17. So we have 17. This is like a determinant of A. So we have it. The next, you calculate the determinant of A1B. Here. Oops. This one, determinant of A1B. What's that? here, the 5, 1, 0, negative 2, 2, 1, minus 1, so minus 1, 2. So like this. So what's that? So here, you can choose third one. The third one, you can choose, this is a third one, the third column. I will eliminate 2. How can you do that? Here, you have to keep 5, 1, 0. You can keep negative 2, 2, 1. It's like the first row, the second row, third row. How can you sum the change third row? Here, the third row minus 2 times first row because I can eliminate 2. The third row is minus 1, minus 1, 2. The negative 2 times minus 2 is positive 4, negative 4, negative 2. You add it. This is 3 minus 5, 0. We have 3, negative 5, 0. So like this. Next, you choose third column. Like third column, this 0 is exactly the first row and the third column. The 1 plus 3 is even number. The even number has positive, negative, positive. This one, you can calculate. You don't need 0. Only second part 1, keep negative 1 times you have to eliminate second row, third column. So we have 5, 1, 3, minus 5. So exactly negative 1 times 5 times minus 5, negative 25. 1 times 3 is 3, so negative 3. So exactly 28. So we have this one. Determinant A1B is 28. That's good. The next tip. Here, you calculate the determinant of A to B. Here, can use black one here. The determinant A to B. I can do that. So we have similar method. So A to B is 3 minus 1, 0. We have 5, negative 2, minus 1, 0, 1, 2. This determinant, so like this. So how can you do that? It's the same too. You can choose your first column. You can keep minus 1 and 0, eliminate 3. I can do that. This is keep minus 1, negative 2, 1, 0, minus 1, 2. So this is like a first row, second row, and third row. How can you do that? So exactly the first row plus 3 times second row. The first row is 3, 5, 0. The 3 times the second row is negative 3, negative 6, and 3. You add it. So we have the 0, minus 1, 3. We have 0, minus 1, 3. The next, you have to choose first column. You can choose here, first column. What kind of sign? Here, positive, negative, positive. You don't need the first and the third one because we have 0 terms. Only use minus 1. You can keep negative and minus 1 times here. So eliminate second row, first column, the minus 1, 3, minus 1, 2. So minus 1 times minus 1 is positive 1. Just minus 1 times 2 is negative 2 minus negative 3, exactly 1. So we have 1. This is determinant A to B. The next, the last one, the A3B, determinant A3 of B. the determinant of A3 B. What's that? The determinant of the 3 minus 1, 0. The 1, 2, minus 1. 5, negative 2, minus 1. And calculate the same things. First row, second row, then third row. You can change it like this. Keep last one and second one. Only eliminate 3. How can you do that? Exactly. The first row plus 3 times second row. First row is 3, 1, 5. Second row is 3 times second row, the negative 3, the positive 6, negative 6. You add it. So we have 0, 7, minus 1. We have 0, 7, minus 1. So we have it. The next, you choose similar. First column, what's like sign? Sign is positive, negative, positive. You don't need 0 terms, only negative 1. This is minus negative 1 times. You can eliminate here, same. The second row, first column, exactly determinant of 7, minus 1, minus 1, minus 1. Minus 1 times minus 1 is a positive 1. 7 times minus 1 is negative 7. The minus 1 times minus 1 is positive 1. We have negative 8. Right? So, almost done. So we have x1, x2, x3 here. What is x1? X1 is determinant of A1B over determinant of A. The determinant of A1B is here, 28. 28 over 17. We have it. What's it like x2? x2 is determinant A2B over determinant of A. Determinant A2B is here, 1. The 1 over 17. The last one, x3. x3 is determinant of A3B over determinant of A. What's the answer? Negative 8. The negative 8 over 17. So that's it. This is the answer. That's good. This is the answer. You can write like this, or you can write the factor x is, x1 is the 28 over 17, 1 over 17, negative 8 over 17. The either one is fine. Either one is fine. Okay, this is like all section. The 3.2 and the 3.3. The only last part, the 3.2 and the section 3.3. Okay, so could you watch this video? Any trouble, any question, send the email to me. This kind of lecture is very helpful for solving your homework problems and studying section 3.2 and 3. Okay, thank you for watching my lecture video.